This is Honors Algebra 2 Pre-Calc. We're doing Pre-Calc Chapter 2.7, which is actually part of our Chapter 6/Partial Fractions exam unit. All right, so we're going to write the partial fraction decomposition for this lovely rational function. So the first thing I need to do is fully factor the denominator, which I'm going to do over here. So I see that there's a GCF of x, and when I pull that out, I'm getting an x squared plus 2x plus 1, which is a perfect square trinomial, right? It factors into an x plus 1 times an x plus 1, which we're going to write as an x plus 1 quantity squared. So what it looks like here is I have three linear factors, but one of them but essentially there's an x plus 1 and another x plus 1, but because of the repeat factor, I'm going to have to behave a little bit differently when I write my expression. So when I write my setup, right, it's going to be an a on top of this x plus a b on top of the first x plus 1 plus a c on top of the x plus 1 quantity squared, right? Because when you have a repeat factor, you do one fraction for each power of that factor up to the top, okay? So now, the reason I picked this problem is because it's the first time we're going to run into a challenge where we have to be a little more creative when we're figuring out the common denominator. So what I want you to notice is that the common denominator that I'm aiming for, right, is an x plus 1, and another x plus 1. This is the denominator we need. It has to be identical to the one on this side. So what you need to do is you have to ask yourself what each fraction is missing, okay? So let's start with the x. This is a pretty easy one. The x has the x, but is missing both of the x plus 1s. So it's missing an x plus 1 times another x plus 1, right? That's what's missing from this fraction, is both of the x plus 1s, okay? But when we get to the second fraction, it has one of the x plus 1s, meaning it is only missing the other x plus 1 and also the x. So it's missing the x and the other x plus 1. This one's missing the x and the other x plus 1, right? But then when we get to the c over the x squared plus 1, or x plus 1 squared rather, it has both of the x plus 1s. It's only missing the x, right? So what's going to happen is my common denominator for all of these is an x plus 1, another x plus 1, and an x. And that's what they all need to have. So my numerators only, right, my numerators only are going to look like a 4x squared plus 3x plus 1 equals the a times the x plus 1 quantity squared plus the b times an x and an x plus 1 plus the c times the x, because the c fraction had everything but the x, right? Now, there's a couple options here, but what I want to point out is that clever substitution can't possibly get you the whole way there, and here's why. If I pick x is -1, it's going to knock out both of these guys and let me find c very easily, right? Because the x is -1 will knock out these two. They'll get knocked out, and I'll be able to find c quickly. Similarly, if I pick x is 0, it's going to knock out the term where there's a bx and the cx. So I'll be able, if I pick x as 0, I'll be able to find a easily. I won't be able to find b using either of those because in b, it uses both factors, so b will get knocked out by both of them. My argument would be, though, that you've already plugged in x is 0, which was easy. You've plugged in x is -1, and when you've done that, you've found both of these terms. So you could pick another easy x, which I would probably pick x equals 1 because we haven't used it and it's an easy x, and that would let you find b, and that's just fine. The other option that you have here, if you don't want to do that, is that you could FOIL all of this out and then do the thing where you make two matching, essentially, systems of equations, right? A left-hand side that equals a right-hand side. I'm going to walk you through both. Again, in a real problem, you would never do both. You would pick one. So let's do clever sub first. I notice that if I pick x is -1, it'll knock out both of these. So if I do clever sub and pick x is -1, I'm going to get a 4 minus a 3 plus a 1 equals a bunch of zeros, and then this will be a c times a -1, so it'll just be a -c. So seems to me that I get that 2 equals -c, right? Which means that my c is a -2, right? And that wasn't too hard to find, right? I'm then going to do the same approach, but I'm going to use x is 0 to knock out both of these chunks, right? If I use x is 0, I'm going to get 0 plus 0 plus 1 equals a times a 1 squared, which is just an a, plus a bunch of zeros, right? So I seem to get 1 equals my a, which is also not super duper stressful. Now that I know a and c, I would make the argument that you could pick literally any easy x and plug in and find b, right? If I did that, the easy x I would pick is 1, because again, if I have the choice, I try to pick positive numbers and I pick things that I can easily square without feeling stressed. So I get a 4 plus a 3 plus a 1, equals, well, we now know a is 1, right? So this is 1 times a 2 squared, right? Because it would be 1 plus 1 squared. Plus, we don't know b, but we know x is 1, so that's a 1 times a 2. Plus, I do know c, it's a negative 2 times that 1. So if I clean this up, I get 8 equals, on this side I have a 4 and a negative 2, which seems to be a 2 plus 2b, right? So 6 should be my 2b, so 3 is my b. And that's fine. I don't think that's really, I mean, it's definitely a more involved problem, but it's not awful. So we're going to slide this over and put our answer here again, right? So the answer I'm going to write is my a over x. Well, my a was a 1, so 1 over x, plus my b, which was a 3, over this x plus 1, plus my c, which was a negative 2 over the x plus 1 quantity squared. And that's fine. Again, if you want to make this last one a minus a positive 2, it's fine. I would just not suggest that you risk it. So now let's go back and do this the other way in case you are a person who desperately wanted to see how to do it the other way, or in case you pick the other way. I won't always do this, but I think it's helpful here if I do it a little. So it's worth knowing we should be able to FOIL x plus 1 in our head pretty comfortably. It's an x squared plus 2x plus 1, and even if you couldn't, you actually already did it over here. You did the reverse because you factored it. So I get that this is a 4x squared plus 3x plus 1 equals ax squared plus 2ax plus a. When I distribute this, I get plus bx squared plus bx, and I get a plus cx. So at first glance, this is already a slightly better situation than it was before because I can find a very quickly. What I want you to notice is if I do my left-hand side equals the right-hand side, right? I have x squared terms, which we'll deal with. I have x terms, which we'll deal with. And I have numerical terms only, which we'll deal with. So I'm going to start by noticing that there is only one term on this side that doesn't have an x. Everybody else has an x. So right away, a has to equal 1. So that's great, because now that I know a is 1, that's going to help me solve other things, right? If I look at the, let's go back up and look at the squareds. On this side, I have a 4x squared, so 4 has to equal, well, the x squareds on this side are an ax squared plus a bx squared. So 4 has to equal a plus b. Well, that would be more stressful, except we already know a is 1. So 4 has to be 1 plus b. Oh, look, b is 3. Right? So that's fine. So I've already got a and b. So now really, no matter what they throw at me, I should be able to find c pretty easily. So on this side, my x terms are a 3, and my x terms on the other side are a 2ax plus a bx plus a cx. So that's a 2a plus a b plus a c. Well, that would seem stressful, except I already know the values of a and b. So I get 3 equals 2 times 1, which is 2, plus 3, because that's my b, plus c. So I get negative 2 is my c, and then I end up with exactly the same answer I had before. So again, which way you choose to do this is up to you. They'll land you in the same spot. Sometimes one of them is slightly easier than the other.